So 9.3 and 9.4, we have all sorts of little equations, right? For the macroeconomic side, the 9.4, and I think if we went back and looked at, so probably go like, if you look on page 554, that example with the demand function, where we took all the company did a survey, right, and they got how many widgets somebody would be willing to buy at a certain price, right? And we put it in and did a linear regression, right? And we got, so the quantity demanded was Q equals, and the slope was negative, right? Negative M times the price plus some B, whatever it was when we got the regression out of it. But the demand is always going to be negative there, right? Negative slope, because the higher the price goes, the lower the demand is, right? Okay. And then in 9.4, we had some expense equations, expense functions. So the first one was just, your expenses are just the combination of the variable plus the fixed, right? Can't remember what the variable ones are, the cost it takes to manufacture each individual item, and the fixed are the stuff that, whether you manufacture any or not, you still got to pay for your lease and your stuff like that, right? But then the variable side of it, right? That's, so to get the variable expenses, it's the cost to make each widget times the number of widgets you make, right? So V equals the cost to make each one times the number you make, right? So then we could substitute that in for V in this one, right? So then we had expenses equals CQ plus the fixed, right? And so this is in terms of quantity, right? The demand function is in terms of what? Price, right? Okay. And then at some point, they were asking, find the expenses in terms of price, right? Well, here's my expense function in terms of quantity, but I want to have a P in there instead of a Q, right? So I took what this Q is actually equal to, right? This stuff, plugged it in, right? So then we did like E equals C times whatever that demand function was, negative MP plus B, and then the part you forgot to do on the homework was, right? After you distributed, right, you got to add that in. So now you got your expenses in terms of the price, right? Instead of in terms of quantity. Then we had a revenue equation. Which one do you take in? Revenue function. Well, that's the money you get from selling, right? So it's whatever your selling price is times the number you sold, right? So revenue equals price times quantity sold, right? So that's in terms of price. And then what do we talk about? Oh, break even. So when did we have break even? When does that happen? When what? Yeah. Equals expense, right? So when R equals E, or the two things are equal, you subtract one, you get 0, right? Either one of these, R minus E equals 0, when that happens, okay? Oh, yeah, so just plug in some of the revenue equations, PQ, right? So if that's my R, right, here's my E. You solve that by doing, okay, when does revenue PQ equal expense CQ plus F, right? You go through and solve for Q. So I put a little rundown from yesterday, and it was a lot of, they're simple equations, but you might have had your brain hole blown because we did a lot of things with it, right? Okay. So anyway, let's go on to 9.5. We're on page 564, huh? Oh, yeah. Yeah, if I ever forget that, remind me. All right, so 9, 5. We get a little deeper into this now. We're going to graph some of these things. So 9, 5. Well, this is going to act up on me again. Graphs of expense and revenue functions. Then we have our graphing calculators to help us. Some of these are so easy, it's almost quicker to do them by hand, right? So let's review a little bit from algebra. Linear equation. If you remember what that is, that just graphs a straight line, right? Okay? And what's the highest variable, or what's the highest exponent on the x?
Basically, in coding packet, which reports the net, coding packet, and basically reports the net.
The highest exponent for a linear equation is 1, right? Like mx plus y equals mx plus b. Right? There's a 1 exponent on it. We don't write it, right? Okay? And if the highest exponent is 1, I don't know if you heard this in algebra now. We call that a first degree equation. You guys cover first and second degree. It's easy. It's not hard. So it's another way. So linear is also known as a first degree equation. All right. So a graph like this, right, is just basically a line. Okay? A straight line. Could be going the other. And I know you guys graphed quadratic equations. Right? And when we manipulate some of these equations that we've learned already, they're going to end up being quadratic. And what is that? What's the highest exponent for a quadratic function? X to what power? Space. Second power, x squared, right? Something with x squared in it. So it might look like y equals, I don't know, ax squared plus bx plus some number c, right? A, B, and C are just coefficients, numbers, remember that, right? And well, what degree would this be? The highest exponent's 2. Second degree, right? And do you remember what the graph of a quadratic looks like? What's the shape of the quadratic when you graph it? X squared? Not a straight line, is it? Yeah, it starts with a P. What is it? Would it say get parabola? You get those at Sopranos, man, they're delicious. This is a parabola. Right. So it might look something like this if it's concave down, right? Or, it might look like this if it's concave up, like that. Okay. And then up here, like if you had this, that was a vertex, right? We're finding the vertexes of these things. So this is the vertex. It's some coordinates x, y. And you also had, that goes to the vertex, that axis of what? Anybody remember? Going back here a little bit. Axis of symmetry. Oh, and by the way, if it's concave down like this leading coefficient, the A, what did you know? What do you remember about it? To make that parabola concave down, that number in front of the x squared has to be what? Negative, right? And if the number in front of the x squared is positive, it's concave up, right? Remember that? Okay. Another way to say, negative would be less than 0, positive, you could say it's greater than 0. Now define the equation of this axis of symmetry. Let's review that real quick. So for the axis of symmetry, You remember what you do? X equals, you have this equation in this form here. Anybody remember? You have numbers in front of the variables, the A, the B, there, and the C. All right, it's been a little while. So whatever these A's and B's are here, it's negative B over 2A, right? That'll find you the equation, that line that goes right through there. But then the vertex, remember that's an x comma y coordinate, it's just a point. Well, if you found the equation of that, right, you got your x for the x comma y, right? Wouldn't this be the x? And then how do you find the y coordinate once you figured out what the x is? Plug it back in and get your y, right? So the vertex, x. So that's really x comma y, but that's my x. So it's negative b over 2a comma whatever the y is when you plug that in. Right? And the important part, so I mean, you learn how to use these, right? So here's where this is going to come in handy, right? If this is a graph of something we're doing in the real world or financially, or something that's happening, if this parabola is concave down like that, that vertex point, what would it represent? Yeah, some maximum value, right? Or if it's concave down and you found the vertex when it's concave down, that would be a what? A minimum, right? You got maximums and minimums, okay? So to find like a maximum, you're going to do this here, right? And then plug it in and get the y value out, and that's the maximum value, right? And so now you learn how to do these, I think, just to the raw context of mean graph equation, right? We find vertex back in algebra, but now they're going to mean something, okay? That makes sense. All right, so we'll look at some examples here. Example 1, and I think all the examples, they kind of follow this Picasso paint. So like example 1, 2, 3, I don't know. I think it goes all the way through. If I'm mistaken, we'll find out. Let's take a look at the first example there. Whoopsie daisy. Hey, Simone, read example 1, would you? Okay, so stop it. So they got that that demand function, just like that example back in the book where they did a survey, did a linear regression, right? So they got that Q equals negative, right? 500p, right? Go ahead. Okay, so we can get an expense function, right? But our basic expense function is not in terms of price, it's in terms of what? Well, quantity, right? Expense, of course. Yeah, expenses in terms of expense. All right, so we need our expense function, E equals, remember the variable CQ plus the fixed, right? And we need to get that in terms of price. But let's get that function first. So what they give us in the problem, right? Let's work on the C part of it. What's the C? The cost to manufacture each one. Okay, so we have E equals 7Q plus, and did they give us fixed expenses? 28,000 or just 20? $28,000. Okay. So we have expenses in terms of quantity, but they want it in terms of price. Well, here's our demand function. What was it? Negative 500p plus what? 30,000. That's in terms of price, right? So how do we get expenses now here in terms of P, price? Do you see a Q in the expense function? Do you see what Q equals? When things are equal, we can replace them, right? So let's substitute this Q in. So we'd have E equals 7 times this mess. Don't forget to put this on the end, plus 28,000. Right? Now we just kind of distribute through and simplify the thing. So sometimes we have a negative 3,500 P, negative 3,500 P, plus 7 times 30, 210,000, right? Plus 28,000. Just distribute it through, and now we just combine those like terms at the end, right? So we get expenses equals negative 3,500 P plus 210, 228, what's that, 238,000? Okay. Is this quadratic or linear? What's the highest exponent on the variable in there? The variable's not x now, it's p. So what's the exponent? It's a 1. So it's linear, right? It's just going to be a straight line. All right, so it's like mx plus b. You can look at it that way, right? Another way to do it is use the intercept, right? How many points to find a line? 2, right? Couldn't the x and y intercepts be those 2 points? And where do you find the x-intercept, or y equals what? 0, right? And the y-intercept is where x equals 0, right? It makes sense, right? If you're crossing the y-axis, x is 0 there, wherever you cross it, and vice versa. So let's find, to graph it, the intercepts, the x and y intercepts. Well, the y-intercept, well, it's going to be the E, right? It's actually going to be the x would be the P and E intercepts, right? X and Y. I think the easy one here would be to find the E intercept. That's going to be where P is 0, right? Right? So let's find that one. So E intercept will equal, what's negative 3,500 times 0? Plus 238,000. There's one of our intercepts, right? That'll be on the y-axis. Okay? Let's find the P-intercept. It's where E equals 0 now, right? So let's just do it this way. So negative 3,500 P. So this is a little bit more, plus 238,000 equals, my E is 0, right? You can do that, right? Subtract 38,000 from both sides, then divide both sides by negative 3,500. All right, so you have negative 3,500 P equals negative 238,000. Guys, what does P equal? Here, get on your calculator and do that. $68. So hey, here's my E or my Y-intercept, my P or my X-intercept. We can sketch a quick graph of this, right? We got 2 points now to find a line. Let's figure out how we're going to do this. So we'll do that. So this will be normally the X, but it's our P axis, right? And up here would be our expense, our E axis. Let's figure out how we're going to number it. I don't know. So we don't have to get too nuts here. What if we just like count by tens until we get up to like 70? And then we can, right? So let's do 10, 20, 30, 40, 50, 60, 70. Anyway, that's 70, right? 60, 70. So 68, that'd be right about there, right? For the p-intercept, right? You get that. That's where expenses are zero, right? So that's it, right? So visually. Oh, we got to get to like 240,000, right? I don't know. What's that? I mean, how about we just do this? Because we're, you know, zero. We'll call this 240K, about 120K, and zero. So wouldn't 238,000 degree be about there, wouldn't it? Yeah. We're just gonna go through points of the line now. And there we go. Whoops. Not a very straight line. Should be straight. You guys grad lines with the intercepts method, didn't you? Before? Okay. All right. Sometimes they don't do that, or they didn't used to do that. I just want to make sure. So you just remember, you just find the intercept by putting a zero in for one variable, and then find the other one, putting a zero for the other one. It's not too hard. Okay? So there's the graph of that, and it's in terms of price, right? So as the price you sell it for increases, why would the expenses go down? Well, where did the price come from, by the way? It came from what function? What was this? Wasn't this the demand function? Right? So as the price goes up, the amount you're selling does what? Goes down. So if we rewrite the expense function, as the price goes up, the number we're selling goes down, so the number we're manufacturing goes down, so the expenses go down. Does that make sense? Connect those two, right? You plug one in. Now we have one in terms of the other. Okay? Did that confuse you guys, or can you go back and take a look at something? Okay? We've done it before, just now it's like in the context of a real life problem, right? Okay. I don't think we're going to do, yeah, we're not going to do a check. It's an example two. We're still on Picasso pace. Dylan, read example two. Just going to follow up on this one, I'm sure.
What is the revenue function for Picasso product? What the revenue paid in terms of price?
Okay. So remember, revenue R equals what? PQ, right? P, price you're selling it for, Q times the number that you sell, or the number of them that you sell, right? And they want that, again, in terms of price, right? Well, that's in terms of quantity. But we still have that, we're still using that same demand function, right, from the previous example, right? So we're still using the same demand, which was the Q equals negative 500 P. What was it, plus what? 30,000. Okay? So now we're going to get something a little different than we had yesterday. So we're going to just substitute in the Q, right? So now we can do revenue equals price times Q, negative 500 P plus 30,000. Okay, so here's where this gets a little different than what we had before. We're going to distribute through here. So revenue is going to equal what when we distribute? Or distribute the P through. Hmm? Where does 7 from? No, we're just using the, we're just distributing that P right there through there, distribute it through. What is P times negative 500P? So negative 500P squared. Go ahead, plus 30,000P times price. Now we don't have a linear function. What do we have? Quadratic. And the graph of that will be a what? A parabola with cheese. Right? Or parabola. Okay? Now, is this going to be concave up or concave down? Down, because of that negative A. Remember, so this is my A, right? And that's my B, and C is 0, right? But x squared plus bx plus c. There's no c, so c is 0, right? Okay. Well, let's figure out how to graph this thing here. We can use a calculator, right? Wait a minute. Wait, did they ask us to wait? Oh, no, they don't ask us to graph it till later. Next example. I don't want to use a calculator. So it's going to be concave down. So it's going to, just a rough sketch of it, right? It'll look like that. Okay? I think the next example they asked us to graph. So this one, I want to make sure you can do this. Oh, wait, no. Yeah, but do the check there. Okay? I want you to determine the revenue if the price per item is $25. Well, there's our function. I'm just going to plug it in. So we're going to use that in a price P of 25. Tell me what you get. Did I write something wrong? No, yeah, you just plug it into 25 people, yes. It's this. That we're plugging P into this equation. Yeah. Yeah. That's the revenue function, and then the check was just, all right, how much revenue they get if they sell them for 20. The price is $25 if they sell them. Get something? Well, and you guys. $437,500. So if they sell it for that much, it's $437, $437,500 in total revenue, right? Selling them for $25 a piece. Okay? That's not profit yet, right? That's just revenue. Remember, profit is revenue minus expenses. Okay? All right. And by the way, if we graph this revenue function here, right, where would we find the maximum revenue? Like if this is the price you sell it for, right? Notice as the price would go up, right? The revenue starts to climb. And then if the price keeps going up, why does the revenue start to dip? Because the demand at some point starts to go down, right? It starts to tail off as you go up, right? So you got demand, the demand is getting smaller, right? So they're not selling quite as many, right? And then they're really not selling, right? At some price, you're just not going to sell any at all, and you're going to get zero revenue, right? So like if you sell 0 of them, 0 revenue. If you price it too high, nobody's buying, back to zero revenue. Does that make sense? And then where do you find the maximum revenue? At the what? Right? So whatever that price is here, right, will give you the maximum revenue based on the demand function, right? Okay. Let's kick it over to example 3. Now I think they want us to graph that. We can do this without a calculator, by the way. We could find the vertex and the two intercepts, couldn't we? Are there not two x-intercepts in a vertex? So example 3, just graph it. All right. So our revenue, here it goes again. Our revenue function is R equals negative 500P plus 30,000P. Okay. So we need more than 2 points now, right? We need like at least 3 to get some reasonable parabola in there. Hi, Carly.
Hi.
We're on 9.5, page whatever. 5, they can tell you what page. 67, 560. Okay. So let's find some intercepts here, okay? Okay. Oh, in other words, we're going to find some zeros. You remember finding zeros of a function, don't you? Zeros are also the intercepts of it here. So let's take this thing and set it equal to 0 and see where it hits the x or the p-axis in this case, right? So let's take this. Right? Set it equal to 0. Now there's all sorts of ways you can solve these, right? You did the quadratic formula, right? You've done that, yes? Negative b plus 1 squared p squared minus 4 squared over 2a. I don't get that memorized. Yeah. Or this one, couldn't we just factor it and solve it? What can we factor out of both of these terms here? What's the just factor out a p. So we have p times, oh, that's p squared there, by the way. I forgot that. Sorry, there's a square on there. So if we factor out a p, we have negative 500 p plus 30,000, right, equals 0. So now we have 2 factors, so now we just set them both equal to 0. So either this factor p equals 0, well, that's easy to solve, it's already solved itself, right? Or negative 500p plus 30,000 equals 0. Let's subtract 30,000, so we get negative 500p equals negative 30,000. So what does this one equal? No, what is that p? 60, right? Divided both by negative 500. So we have 60. So there's an intercept, right? Right. So revenue, this makes sense, right? So the revenue will be 0 when the price is 0, right? If you're selling it for $0, you're not getting any money in, so that makes sense. But then as you increase the price out to $60, right? That demand is slowly tapering off, right? And then it'll hit, no one's going to buy it for $60, in other words, right? Now, we need a third point. How about that vertex? How about the vertex? X equals negative b over 2a. Instead of using an x, we use a p. P equals negative b over 2a. Well, what is our b up here in the equation? ax squared plus bx plus c. What's our b? Right, so okay, so negative 30,000 over 2 times, what's the A? Negative 500, right? So that's negative 30,000 divided by negative 1,000. And that should be easy. What is it? 30, isn't it? So 30. But we need the revenue that goes with the price of 30 to get the coordinates of that vertex, right? So how do we find that? So negative 500 times 30 squared plus 30,000 times 30. Go ahead and push your buttons. Yeah. So this, is that what you meant? That's 0? So we got the T, let me box that in. So we got that one, and then that one. We just need that third point. We need, it's not linear, right? We need third point to define, kind of define the curve. What is that value? 450,000? Right, is that right? That's right. So the coordinates of that vertex are 30, comma, 450,000. So there's that third point where we can kind of sketch out, right, the parabola. Now, if we were really going to try to be accurate, we need quite a few more points to put in there, right? Okay. And I know you guys do this with your calculator, you get it all right then and there, but what's the name of this class? Financial what? Hey, that's algebra. Okay. We stick with the theme here, I think, right? All right, so we've got 3 points to put our parabola in here somewhere, right? So let's, I don't know, like this. Make sure we got plenty of room. Now remember, this is our price axis, not the X anymore, and this will be our revenue axis instead of the Y, okay? So, I don't know, why don't we count along the price axis by tens until we get to what? 60, okay, good to me. So, 10, 20, 30, 40, 50, 60, that's fine. Okay, so we have this here and that there, right? So we got to make this thing come up, right? And so that's why we need that third point. You follow me? Right? How do we make it? Where does it go? So so we got to go up to 30, comma 450,000. So maybe we'll go up. Let's count by 50,000s, maybe up here. So 50, 100, 150, 200, 250, 3. 350, 4, 450. So we're going to put them all in there. 50K, just enough to tell somebody what we did. I think that seems like a reasonable interval. Okay. Mm-hmm. A little bit. They'll be available. All right, so let's plot the 30, comma 450,000. That's our vertex. And now we'll draw our nice smooth curve through it like that. And there's our revenue function. This is our 30, comma 450,000 point. Okay? Mm-hmm. That's the revenue. So if we set a price of $30 per unit to sell it for, our maximum revenue will happen there. And that maximum revenue, if we sell them for $30, is $450,000 in revenue. So I went that price. No, it doesn't. Look again. Okay? Now, okay, let's make sure you get this part here. Why, if I raise the selling price to $40, does my revenue go down? Because this it had the demand function plugged into it, right, to get it in terms of price. Okay? Now, if this were just quantity, right, you'd expect it to just be a straight line pretty much, right? But we've got it in terms of price. Okay? So you guys think you could do that on your own, right? You just, the first linear graph, 2 points to final line, we use the X and Y intercept, right? This has got a curve to it, so to at least figure out how high it goes, we need that third point, right? And that's the vertex, right? That's that negative B over 2A thing, which got us our 30. And then you plug that in and get that, okay? And I know those machines will do it for you, but I'm not here to teach you how to use a machine. Otherwise, we have to read the entire class and call it financial calculator skills. It's a waste of my time to teach you something you can get from a calculator user manual on your own, right? Okay. I want to do the check there. There's example 3. Yeah, take a look at the check. Just read that over real quick. See if you can answer that. Stick that in. We got room to save some space. So here, we'll just put the check here, I think. What do they want to know there? Yeah, which would yield a higher revenue, $28 or $40? Just looking at the graph, they said. We kind of address this, right? So $28, right? If you go up, you're pretty close to that max, right? Well, what about 40? It'd be less revenue, right? So for this one here, the 28, you get a revenue. You're pretty close to your vertex, but 40, we go up from there, quite a bit less, right? Because the demand is going down, right? I mean, you could plug in 28 and 40 to the equation and figure it out, right? But we got a graph for a reason, right? So it's the $28. Okay? And why is that? Right. It has more demand than at $40. That makes some sense. All right? Okay, so we have one more example to do. We're going to skip the we did the factory just now. We're going to skip that part. We're going to skip the completing the square. You guys already know the quadratic formula. That's there on page 568. If you want to avail yourself of it at some point. Okay? And we'll skip an example 4. We'll finish this up all the way at the end with example 5. Okay? So they've graphed the revenue expense functions. So basically, between example 3 and example 1, right? We've got a parabola for the revenue, and then what the expense one was a straight line. Okay? And they're asking us about the points of intersection. Well, let's figure out what they are. Let's just roughly graph that. They're not, I don't think they're really asking us values here. So let's do, I'm going to skip here. This won't take long. So we're going to take both the graphs that we had. Right? It's all in terms of price. Here's price, right? So we'll just call this the money side, right? Whether it's expense or revenue, right? We've got both graphs on here. So we're going to have, here was our revenue graph, right? Okay. And then we had an expense graph. And notice that there are two intersection points, aren't there? And let's label it the way they said here. So points A, B, so we have okay, so we just make sure we know this one is revenue. And this one is expense. Okay? And they got point A and point B right here. There and there. Okay. Let's figure out what, oh, they have a, oh, C and D, sorry. So this is a C, and over here they have point D. Those are points we found. Well, hello, Mercedes.
Hello.
Boy, you miss a lot when you sleep in.
I know, and I wasn't sleeping in actually today. I had a lot of stuff I had to do to college.
Okay. All right, so let's think about what these points are. Let's take point A. So point A. What will be a name? Give a name to point A based on these two graphs. We have revenue and expense, and they intersect right there at point A. Now, careful. If revenue and expense graphs intersect, what do you know about revenues and expenses? That's the break-even. That's a break-even point, right? Profit, if you call, yeah, zero's a number, so yeah, profit is zero, I guess, right? That technical matter, but break-even. In other words, revenue minus expenses equals zero. It's the same value. Okay? What about point B? What would we call point B? That's another break. So there's two break-even points here. About that. So that's a break-even. Okay? What about point C? What can we say about point C? The revenue graph touches it. So revenue equals zero, doesn't it? But are there still expenses? Okay. So we call that a what? Loss, right? We have no revenue, but we have all those expenses. That's a loss, isn't it? Okay, what about point D? Because revenue equals what? Zero. And we still have expenses, don't we? But not quite as many because we're making less because the demand is less here, right? But it's still a what? A loss. Okay? So where do we find a loss? When the price here, when the price is between what and what? When the price is between what two letters? C and A, right? So if we have a price set between, so in other words, if C less than or price less than A, right? That's a loss. With me on that? And I shaded that in red there, didn't I? So basically, anything in here is a loss, isn't it? In that little region there, okay? What about between A and B? What would we call that if we set the price between A and B? What will happen there? Gain, aka profit, right? Aren't revenues anywhere between these 2 points greater than expenses? So I'll do that in green, right? So this would, all of this would be profit. So like whatever your revenue is here, subtract this expense, and that expense is also the profit, right? So if it's between A and B, we have profit. Now it varies in there, right? You might have a little profit or a lot of profit, right? But you do have a profit. And what about when the price is set greater than D? What if price is greater than where point D is? Huh? We got another loss, don't we? So this is loss out here. Whatever. Okay? That makes sense? So you guys remember domain? Domain is all the like the X value. Domain always runs this way. So if our domain is between C and A, right? Domain, it's a loss. The domain is between A and B, profit. The domain is greater than B, we have another loss. Okay? So we have now a different looking revenue function, not in terms of quantity, right? Remember our revenue function yesterday was a straight line. But when we plug in the demand function and get revenue in terms of the selling price, it becomes quadratic. And we have two break-even points. Okay? The profit and loss is hidden everywhere in there. Okay. Let's take a look at the check and just think about answering that. Read that check over. And then we'll have a bow on this one. I was charging price of $7.50, and they have a graph there. So let's see. The way they have it graphed is, I think, right here was 808. What was the other one? 5892 was right here. 58.92. Okay. So why would charging a price of $7.50 or $81 not be in the best interest? Say again?
61, not 81.
What's 61 to 81?
Said 81.
Oh! 750 to 61. Yeah. All right. Why would that not be in the best interest of the company? Right? To such a degree that the company would experience a loss outside. 750 here, 61 or 81. So it really didn't matter, Dylan. 81 would have worked there. Okay? Because both of those numbers are outside the profit. This is our profit domain, right? From 808 to 5892. So the way to answer that mathematically, right? So both of those prices are outside the profit domain. Because both prices are outside the profit domain. Of 808 less than P less than 5892. Right, so I write the domain with the values of P or X. Okay? You're outside that domain, you've got a loss. Within there, you have profit. But again, like even if you're operating in here, we'll see in a little while, right? You could get a little bit of profit, or right in here, be a lot of profit, right? Okay, so we'll figure out how to like price for the highest profit in the next section in there, because we're going to be working in that little sliver in the middle. Anybody have any questions on this? Your brain holes blown wide open? You'll be okay? Okay.